First thing we're going to do is find the total resistance. The way I do these problems is I fill out the VERP chart and then I go into WebAssign and punch in the numbers. Now, all I'm putting into the chart right now is my given information. As I said, we got to figure out the total resistance of the circuit before we can do anything else. R1 is in series with everything. R2 and 3 are a parallel branch. So what I need to do is figure out what single resistor could replace R2 and 3. So I'll go 1 over 15 plus 1 over 61 equals 1 over R. So 1 over 15 plus 1 over 61, that gives me 0.0831 is 1 over R. And do the reciprocal, and I get 12.0. So 12 goes into here. That makes the total 18.0 ohms. Now I'm going to get the total current. 120 divided by 18 gives me 6 2/3 or 6.67. So 6.67 amps run through the battery. They will go right through R1, get to here, and split. They'll rejoin here and go back to the battery. Now, that means all 6.67 amps go through R1. They don't have a choice. There's no other path. The result is, by doing V equals IR, 6.67 times 6, R1 consumes 40 volts. If I take a look at a voltage perspective of what's going on, this line on this side of the battery is 120 volts. Then when I cross over the resistor, which consumes 40 volts, I'm left with 80 volts on this orange line. And my last line, the return line, or on the other side of the battery, is always going to be at 0 volts. The reason is the battery boosts 0 volts to 120 volts. That's why it's 120 on one side and 0 on the other. Now I see R's 2 and 3 bridge a gap between an 80 volt line and a 0 volt line. So these are both 80 and 80. 80 divided by 15 gives me 5 1/3, so 5.33. 80 divided by 61 gives me 1.31. If I add these two numbers together, it comes very, very close to 6.67 or 2/3. 6 2/3, that is. That makes sense because the 6 2/3 current would go ahead and split. Power, I'm not going to actually do the power on this. It's a plug and chug equation. P equals IV, 40 times 6 2/3, 80 times 5 1/3, 80 times 1.31, 120 times 6 2/3. You can do that one on your own. Let's move on to the next question. Again, assemble the VERP chart, VIRP, R1, 2, 3, 4, and T for total. This is 4, 14, 3, 5, 120. Just like last time, R's 3 and 4 are in series with everything, and then I have this parallel branch, which I need to figure out. The 2 in series, this is 3, and this is 5, so my goal is to figure out, well, what goes in here? 1 over 4 plus 1 over 14 is 1 over R. Grab a calculator, 1 over 4 plus 1 over 14 is 0.321. Take the reciprocal of that, I got 3.11. So 3.11 goes in here. 3.11 plus 3 plus 5, that's going to give me 11.11, or 11.1 as we'll go 3 sig figs. 120 divided by 11.1, that gives me 10.8 amps total for the circuit. So 10.8 amps come out of the battery. Those 10.8 amps go all the way to this intersection here and split. They will recombine here at 10.8 amps, go through R3, go through R4, back to the battery. So this is 10.8, this is 10.8. 10.8 times 3, that gives me 32.4. 10.8 times 5, that gives me 54. So R4 consumed 54, R3 consumed 32.4. Taking a look at voltage, This line outside the battery, off its positive terminal, 120 volts. This line on the negative side of the terminal, 0 volts. This line between 3 and 4 is 54 volts. 54 volts go into R4, R4 consumes 54 volts, 0 volts come out. This line on the other side of R3 be 54 plus 32.4, 86.4 volts. 86.4 volts go into R3, 32.4 gets consumed. That leaves us with 54. So now looking at R1 and R2, they are bridging 120 volts down to 86.4 volts. So 120 minus 86.4, they each consume 33.6 volts. They should split up the 10.8 amps. Let's see if they do. 33.6 over 4, that's 8.4. 33.6 over 14, that's 2.4. 8.4 and 2.4 do indeed add up to 10.8. Power, once again, P equals IV. I'm skipping that in the interest of time. Next, V, I, R, P, R1, R2, R3, total. R1 is 12, R2 is 9, R3 is 5, total voltage is 40. So, getting the total resistance per usual. This circuit looks very similar to a straight up parallel circuit. Here's R1 at 12 ohms. And this line here, this is 14 ohms. The reason is if you go through R2, you must go through R3. There's no alternative. So instead of thinking of it as 9 and 5, I'm just going to think of it as 14. 1 over 12 plus 1 over 14 is 1 over R. Grab a calculator. 1 over 12 plus 1 over 14. Hit equal. You get 0.155. Do the reciprocal. 6.46. So 6.46 is our total resistance. 40 divided by 6.46 gives us a total current of 6.19. Now the thing is, that's not going to be as helpful to me this time as it was before. The 6.19 amps splits right here. It rejoins right here. So 6.19 amps doesn't go through any single resistor. So voltage is how I'm going to have to solve this one. This line is 40 volts. Our return line, 0 volts. I can see R1 bridges 40 volts to 0 volts. So R1 consumes 40 volts. 40 over 12 gives me 3.33 amps. Now the question is what happens to 2 and 3? Let's imagine we can kind of zoom in on the circuit, specifically right here. So if I were to zoom in on that circuit, I would end up at a magnification of a wire running vertical and another wire running horizontal, like so. Now, what I have here is a path to R1. This is a path to R2 and R3. This comes from the power source. This line is bringing in 6.19 amps. This line takes 3.33 amps. So 6.19 minus 3.33, that means 2.86 amps continue on to R2 and R3. So we'll go 2.86, 2.86. The combined voltage of 2 and 3 should be 40. As you can see, this line's 40, this line's 0. So the two of them combined, again, that's combined, should be 40 volts. And let's see if it is. 2.86 by 9, that gives me 25.7. 2.86 by 5, that gives me 14.3. And sure enough, it comes out exactly to 40. Last one, this one here, VIRP, R1, R2, R3, R4, R5, total. Total is 120 volts. Resistances are 2, 17, 12, 20, and 9. I have a 2 ohm resistor before I get to this parallel branch. In it, I have a 17, and then I'm going to call this one a 32. If I go through R3, I am going through R4. There is no alternative. So we're going to start by figuring out what is this parallel section here doing. 1 over 17 plus 1 over 32 is 1 over R. Grab calculator, 1 over 17 plus 1 over 32. You get 0.0901. Take the reciprocal, 11.1. So now this circuit is effectively a 2 ohm, an 11.1 ohm, and a 9 ohm circuit. So that's going to total 22.1 ohms. 120 volts divided by 22.1 ohms gives me 5.43 amps. 5.43 amps comes from the power source, goes through R1, reaches this intersection here, splits, reconnects here, goes through R5, back to the battery. So 5.43 amps for R1, 5.43 amps for R5. Voltage, 5.43 by 2, that's 10.9. 5.43 by 9, that's 48.9. So this one consumes 10.9. This one consumes 48.9. This line, 120 volts. This line, 0 volts. This line, 120 volts, except R1 consumed 10.9. So that leaves 109.1 volts. This line, 48.9 volts. 48.9 going to R5. R5 consumes 48.9, 0 volts come out. I can see now R2 has bridged the gap between 109.1 volts down to 48.9 volts, so it had to have consumed 60.2 volts. Just like in the last problem, R3 and R4 combined will consume 60.2. The current, 60.2 divided by 17, that gives me 3.54. So focusing at this intersection, 5.43 amps come in, 3.54 amps head off to the R2 resistor, 5.43 minus 3.54. That leaves 1.89 amps to go to Rs 3 and 4. 1.89, 1.89. Do the voltage, 1.89 times 12, you get 22.7. 1.89 times 20, that gives me 37.8. 22.7 plus 37.8 comes out to 60.5. So why am I off by 0.3? Just a small rounding error, nothing to really worry about. P equals IV, you can run through that.